In match problem 2, we're dealing with exactly the same functions that we had before. In one case, still integrating with respect to y, the other one integrating with respect to x. But now what we're adding are upper and lower bounds for our integration. So we're dealing with definite integrals. So we'll start by taking a shortcut, building on the results that we already know. If we integrate this function with respect to y, we would end up with 2xy squared plus 3x squared y to the fourth. And now what we're going to do is evaluate this expression, since we're integrating with respect to y, from y equals 0 to y equals 1. So what that means is we're still treating x as a constant. We're not going to plug any values in for x. We're only going to make substitutions for y. So this will become 2x times 1 squared plus 3x squared times 1 to the fourth. So that's that function evaluated at y equals 1. And then when we plug in y equals 0, this will go to 0, this will go to 0. So we're subtracting 0 minus 0. So our final answer here becomes 2x plus 3x squared. So again, we never substituted any values for x because we were integrating with respect to y. So we're only evaluating this expression at those upper and lower bounds for y. So similarly here, we already found that this result, when we integrate this function with respect to x, will become 2y x squared plus 4y cubed x cubed. And now since we integrated with respect to x, we'll evaluate this from x equals 0 to x equals 3. And again, nothing here is going to be substituted for y. We're only going to plug these values in for our x terms. So this will become 2y times 3 squared plus 4y cubed times 3 cubed. And then evaluating this as 0, this goes to 0, this goes to 0, so minus 0 minus 0 is going to give us 18y plus 108 y cubed. So our final expression here is in terms of y, just like the original, or the first problem we worked, their final expression was in terms of x. Because we never made any substitutions for y here, we never made any substitutions for x. But this brings us to our final answer for both problems.